Continuous integration is a practice that helps developers deliver better software in a more reliable and a predictable manner. In this video, you will first see how developers face problems while writing, testing, and delivering software to their end users. Once you understand these problems, you'll understand that these problems were solved by none other than continuous integration. Hello everyone, this is Sahiti on behalf of Edureka, and I welcome you to this session on continuous integration. Thank you all the attendees for joining in today's session. Before we get started, all of you just give me a quick confirmation on the chat window whether I'm audible or not. Okay, I've got many yeses. So that's great. So now let's get started with the session. So without wasting any further time, let's look into the topics for today's session. We'll start today's session by understanding what was traditional integration and its problems. Then we'll understand what is continuous integration and look into the benefits of continuous integration. After you understand the benefits of continuous integration, you'll understand the requirements for continuous integration system, and then we'll discuss the ultimate tool for continuous integration, that is Jenkins. Once we brief about Jenkins, we'll discuss more about Jenkins plugins, and then finally we will move on to a hands-on part where we will perform continuous integration with the help of tool Jenkins. Alright guys, so is the agenda clear to everyone? Okay, so that's great. So now let's get started with the first topic for today's session, that is traditional integration. In traditional integration, each developer gets a copy of the code from the central repository with the starting point is none other than the latest stable version of the application. Now, all the developers begin at the same starting point and work on adding new features or fixing bugs. So each and every developer makes a progress by working in a team or on their own. Now, what I'm talking about is each developer is trying to add new feature or is fixing any bug. So all the developers are working simultaneously on the same code. They add or change classes, methods, and functions and shape the codes to meet their needs. And eventually, they complete the task they were assigned to do. So each and every developer performs these actions and they keep changing the code to fulfill the task that they were assigned to. So if we just take a step back and look at the entire project, we can see that all the developers working on the project are changing the context for the other developers as they're working on the same source code, right? So suppose you consider a team of 5 developers. So each one of them is changing the code again and again to just fulfill their features. Now, as teams finish their tasks, they copy their code to the central repository. Now, there are two scenarios that can happen at this point. Either the code in the central repository is unchanged or the code in the central repository is changed, right? So considering these two scenarios, you can obviously see that there's a conflict in the source code present between all the developers. So nobody has the same source code. If developer A is working on feature A, then he has a particular code and that code is not present with developer B at that particular instant, right? So now, as you can see that this created a lot of confusion for handling the source code, right? So what are the main factors that can make these problems escalate? So suppose if there's a big team working on a project, then integrating the code of each and every developer working on the team becomes difficult. Also, the amount of time passed since the developer got the latest version of the code from the central repository is very much increased. By this, I mean that suppose at one instance, developer A has some code with him and there are so many few commits already made, right? So by the time the developer A again gets the code, the time lapse between developers A code and the rest of the team is much increased. Now that I've told you what traditional integration is, let me explain you further with the help of a use case of a company. So we have a company known as eToro. eToro is the leading social trading and an investment network company. This company has 120 services, around 300 servers working on Ubuntu. It has 4 data centers and 2 cloud platforms, that is CloudShare and Microsoft Azure. And finally, it also uses the .NET languages for implementing their codes. Now, as you can see that this company works on a large-scale industry, there were many problems faced by the developers. So now let's look into the problems that were faced by the developers. So when you see the problems with this company, The major problems faced by the developers were they could not build the applications easily. They had to manually deploy all their applications. They lacked uniformity, that is, suppose 10 developers were working, all the 10 lacked uniformity between each other. That is because they were working on different operating system environments and they had to configure it separately to get uniformity between each other. Also, they lacked performance issues, which is like the main trademark for any company because any company in the market needs to have a good performance range, and they had a really slow performance range. And finally, when the complete team was trying to integrate their codes, then they found that they had lack of security between while they were integrating their codes. These were some major issues that the company was facing. Now, what was the solution for this? How could the developers overcome these problems? Well, the answer to this problem was continuous integration. So, what the developers did was they created a continuous integration and a continuous delivery pipeline, which automatically built, tested, and deployed their application onto various servers whenever a new update was committed. So, as I told before, they had 300 servers. So, with the CI CD pipeline, they could automatically build, test, and deploy their application into any number of servers they wanted whenever the update was committed. So, as I was telling you, how did they create the continuous integration pipeline? Well, to create this pipeline, they used the Jenkins tool, which automatically built the application and performed unit tests, that is nothing but the user acceptance test. After that, they integrated Puppet with Jenkins and used to configure the environment and deploy the applications to their servers. This automated the complete process by removing all the repetitive manual tasks and streamlined the environment. That is, it maintained the uniformity between all the developers working in the company. So, this solved a major problem. Now, as I was telling you about continuous integration pipeline, continuous delivery pipeline, now what exactly was this continuous integration pipeline? Now, before I tell you what exactly is the continuous integration, let me tell you how it is done. Well, you have to split the entire chunk of codes into segments first. Then you have to keep small segments of this manageable code. After you make the changes required, you then have to integrate the segmented code like multiple times per day so that everybody has that code, and then finally adopt the continuous integration methodology to coordinate with your team. Now, what exactly is this continuous integration? So, according to Martin Fowler's formulation, continuous integration is a software development practice where members of the team integrate their work frequently. Usually, each person integrates at least daily, leading to multiple integrations per day. Each integration is verified by an automated build to detect integration errors as quickly as possible. Many teams find that this approach leads to a significantly reduced integration problems, and thus it allows a team to develop cohesive software more rapidly. Now, let me explain you this definition in simpler terms. Continuous integration is nothing but the practice of continuously integrating the changes made to the project and then testing them accordingly, at least on a daily basis or like more frequently. Now, automating your build, test, and deploy processes can alleviate many problems commonly happening on projects. Now, in such situations, having a reliable method of integrating changes more frequently ensures that these errors can be found sooner than later so that all the problems are solved before anything major happens. So, continuous integration solves the errors very soon and also helps in integrating all the source codes of all the developers and makes changes together. So now that you've understood what continuous integration is, let me tell you the benefits of continuous integration. So starting with the first benefit we have on the list is continuous integration offers reduced integration risk. Now, when I talk about reduced integration risk, often working on projects means like multiple peoples are working on separate tasks or parts of the code, as I mentioned before. So, suppose a team is building an application and that particular team has 10 developers. So, each and every developer would be responsible for some or the other functionality of that particular application. Now, the more the people, the riskier is the integration. That's because there's a lot amount of code and each developer has his own copy of the source code with a new implemented change. So now, depending upon how bad the problem is or how large the team is, debugging and solving those issues can be painful and can potentially mean a lot of changes to the code. So when you integrate all the changes made by all the developers into a single code, then it could need a lot of debugging and could also be a time consuming work. Now, integrating daily or even more frequently can help developers to reduce these kind of problems to a minimum level so that they do not have to debug at a large extent. Now, that was the first benefit, guys. Now, moving on, the next benefit we have is continuous integration offers higher quality code. In continuous integration, you don't have to worry about the problems and you just have to focus more on the functionality of the code. So, obviously, when you focus more about the functionality of the code, it results in higher quality products. Next, if you use continuous integration, you will observe that if you commit something that breaks the build, you and your team will get the notice immediately, and then the problem is fixed then and there before anybody else pulls that broken code from the central repository. What I'm trying to say is, suppose a developer commits a build onto the version control system and there's some error in it. He will be immediately notice that there's some problem with the code and he should immediately fix it before anybody else pulls that code. So you can just say that the code in the version control works to help people integrate much better. After that, we have continuous integration offering reduced friction between the team members. So, as it is evident that the continuous integration system is an impartial system, that is, it does not offer partiality to anybody. So, if there is any mistake, then that mistake has to be solved. If there is any bug, then it has to be debugged. There's no option left. In such situations, this offers reduced friction between the team members because they know that if there's some problem, they have to solve it without fighting with each other. Also, having different versions and builds of the code helps to isolate and trace bugs efficiently, which makes the work easy for the quality assurance team. So, suppose they have to identify any particular bug, they know how to trace that particular bug and how to solve that bug, right? So, this makes the life for testing people really easy. And last but not the least, we have continuous integration offering less time for deployment. As we all know that deploying projects can be very tedious and time consuming, so automating these projects can be really helpful for the complete team. So, guys, that were the benefits for continuous integration. Now that you know what continuous integration is and what are the benefits of continuous integration, it would obviously draw you to an excitement of what are the requirements for continuous integration system. So, well, there are four basic requirements for the continuous integration system. The first requirement is to have the version control system. Well, version control system provides a reliable method to centralize and preserve changes made to your project over time. So as I was mentioning it before, if a team of developers work, then everybody can use this version control system to pull the latest available source code so that they can add their new features to build any application or to make any change. Also, if you're using on-site solutions, another requirement is to have a spare server or a workstation, or at least you should have a virtual machine. After that, if you do not want to mess with any other servers or virtual machines, and then finally, if you opt in for the self-hosted variants, then you will need to install one of the available continuous integration tools like Jenkins, TeamCity, Bamboo, etc. Right? So guys, these were the four basic requirements for the continuous integration system. Now, as I was telling you in the last point, that there are many continuous integration tools like Jenkins, TeamCity, Bamboo, etc. But out of these, in today's market, the ultimate tool for continuous integration is none other than Jenkins. So let me brief a little bit about Jenkins. And then if you want to deep dive into Jenkins, then you can refer to our What is Jenkins video, which I'll leave in the description box below. Now, let's look into what Jenkins is. Well, Jenkins is an open source automation tool written in Java with plugins built for continuous integration. Well, plugins basically allow the integration of various DevOps stages like the continuous development, continuous testing, continuous integration itself, continuous deployment, and continuous monitoring. So, as it is evident that integration is the heart of the complete DevOps cycle. So, all these stages of DevOps integrate through Jenkins. So, as I just mentioned about plugins, well, Jenkins achieves continuous integration with the help of plugins. Now, plugins allow the integration of various DevOps stages that I just mentioned. So, suppose if you want to integrate a particular tool, you just need to install the plugin for that particular tool. Like, for example, if you want to integrate Git, Maven 2 project, HTML publisher, etc., you just need to install that plugins for these particular tool, which I'll be showing you in the hands-on part, right? Now, apart from that, plugins are categorized into various types like the test plugins, the report plugins, the notification plugins, the deployment plugins, and the compile plugins. So guys, that was about continuous integration. So now let's move on with our hands-on part. In our hands-on, we'll be fetching the path of a project from a GitHub repository and then provide it to Jenkins. After that, it will automatically build the project, and then continuous integration will come into the picture where we want to build a project after a fixed interval of time which can define by itself by using the poll SEM. And then finally, we'll build the Jenkins pipeline to show the continuous delivery. Alright, so is the problem statement clear to everyone? So what we are trying to do is we're going to fetch a path from the GitHub repository and then provide it to Jenkins. After that, we will build the project, and then we want the project to be built at a fixed interval of time again and again by itself by using poll SCM. And then finally, we'll be building a Jenkins pipeline to show continuous delivery. So now let's get started with the hands-on. So to go to the Jenkins tool, let me go back to my virtual machine and then open the Firefox web browser so that I can open my Jenkins tool and show you guys. So let me just open my Firefox web browser. So once our web browser is opened up, we have to go to the port where our Jenkins is allocated, right? So I'll go to my local host port number 8080. That's where my Jenkins is allocated. So let me just go to the port. And you can see that Jenkins opens up. So now you have to just fill in the login details and then you have to click on login. So I already have my login details filled, so I'll just click on login. Now, once you log into your Jenkins tool, you can see the dashboard of Jenkins, right? So on the left side, you have options such as new item, people, build history, manage Jenkins, my views, credentials, etc. And then you have in the main center as welcome to Jenkins, where you can create new jobs to get started, right? So if you have to create a new project, you have to click on this option as new item. So let me just click on that. Now, once you click on this option new item, you'll find this page opening up where you have to basically enter your item name. Now, item name is nothing but your job name. Suppose I put the job name as job 1 and then I choose the type of project to be freestyle project. So there are various types of projects that you can choose like Maven project, pipeline, external job, freestyle project, etc. So here I'm choosing freestyle project and then I'll click on OK. Now, once you click on OK, you can see that you have been redirected to another page where you have to fill in the details for job 1. So what you have to do first is you have to go to the option build and then you have to choose the add build step. So you can see in the options of add build step that there are various options present like execute shell, invoke ant, invoke Gradle script, execute Windows batch command, and etc. So here we will choose execute shell. So let me just choose execute shell and then in the command I'll just type in echo hello world. So what this command will do is this will basically print hello world whenever our build is successful. So once this is done, I'll just save this. And then now you can see that our job 1 has been created. Now you have to build your project, right? So for that, you'll choose the option build now. Now you can see over here that our first build is successfully completed, right? Now what I want to do is, apart from just using the shell commands, I also want to pull a GitHub repository. So how do I do that? So to do that, you just have to click on this option configure, and then once it opens, you just have to go to the option of source code management, and then you have to choose your repository type, right? So my repository type is of Git, so I'll choose the option Git, and then I'll mention the repository URL here. Now, once you mention that GitHub repository, you just have to click on save and then you're done with it. So let me just save this. So you just have mentioned your GitHub repository's URL to pull the code. Now, if you want it to work, you again have to build it. you just have to click on this option build now, and this will automatically build your project. So we just have built our job one now. So now let's just see if it is successful or not. So for that, I'll just click on this last build over here and then check the status. So you can see that our hello world has been printed and our build status stands successful. So guys, that's how you can build your projects, and you can also pull the code from your GitHub repositories and use shell commands. So now that we have seen that our job one is built successfully, now if we want this build to happen again and again at fixed intervals of time, then how do we do it? To do that, let me just create a new job again and show you how to do that. So let me just go to the new item option. So I'll enter the job name as job 2, and then I'll again choose the project type as freestyle project. Right, so once I'm done with that, I'll click on OK, and then we are redirected to this page where we have to fill in all the details or whatever we want our job to perform. So we want our job to pull the code from a GitHub repository. So let me just go to the source code management, and then I'll choose the option Git. Over here, I'll mention the repository's URL. So let me just mention the repository's URL. And then if I want this build to happen again and again, I'll go to the option of build triggers, and then I'll choose poll SCM. So with this poll SCM, every time the build happens at the interval of time you mentioned. So suppose you mentioned 1 minute, the build will happen automatically for every 1 minute. If you mention 2 minutes or 3 minutes, the build will happen automatically at the mentioned time. So suppose I mention it for 3 minutes. So let me just show you the build for every minute. So for that, let me just mention the time limit. So I'll mention 5 stars with spaces. That means it will build for every single minute. After that, I'll just click on save, and this will be automatically applied. Now, what you have to do is you just have to build this project to make it work. So you just saw that the first build happened. So similarly, you can see that for every 1 minute, this build is happening, right? So if you just go to the Git polling log, so you can see the latest build that just occurred, right? So you can see that it has occurred at 6:23 p.m. Now let's wait for 1 minute, and you will see that it will again occur at 6:24 p.m. So you can see that the latest build that just occurred is again at 6:25 p.m. That means the build is occurring every minute, right? So that's how you can automatically build your application again and again at fixed intervals of time. Now, if you have to build a Jenkins pipeline, how will you build it? So for that, you have to go back to the Jenkins dashboard, and then you have to go to the option of Manage Jenkins. Once you go to this option of Manage Jenkins, you have to go to the option of Manage Plugins. So let's just go to the option of Manage Plugins. And then in Manage Plugins, you can see the updated, available, installed, and advanced plugins that are available for you. So to build a delivery pipeline, you need the Build Pipeline plugin. So if you do not have it installed on your system already, then you have to go to the available option and then search for the Build Pipeline plugin here. I already have it installed in my system. So let me just show you. So you can see that it is already installed in our system, right? So what you have to do is you just have to go back to our Jenkins dashboard, and then you have to go to this plus sign. So that is where you create a new view for the jobs. So let's just click on that. And then in the view name, you have to mention any name that you wish to. So let's type in the view name as pipeline. So, and then I'll choose the option build pipeline view. So let me click on OK. So now you can see that your pipeline has been built. So you can see the details for your pipeline. The name is pipeline, and the layouts and the number of displayed builds for your pipeline, and so on. So we have to first choose the job from which our pipeline has to start. So suppose I choose the initial job as job 1, and then I click on OK. So you can see very clearly that our pipeline has the job 1 as our initial point, and then it was built at this moment, at this time. So everybody knows at which time it was built. Now let's go back to our Jenkins dashboard to jobs 1. So when I go back to jobs 1, we have to configure jobs 1 here, right? We have to configure jobs 1 so that it can perform post build actions. So for that, we'll go to the option post build action, and then over here, we will choose build other projects. So what's happening here is you choose job 1 as your initial point, and then you add more number of jobs. So you can add like n number of jobs. So suppose job 2, job 3, job 4, and when the last job comes, you have to choose another option. So that I'll tell you soon. So over here I'll mention job 2. This is the job we want after job 1, and then we can choose either of the options. Trigger only if build is stable, if it is not stable, or even if the build fails. So I'm choosing the option of trigger only if the build is stable, and then I'll click on save. So once this is saved, let me go back to my Jenkins dashboard and then go to job 2 here. So in job 2, I have to configure the build that it has to occur after the build of job 1 is done. So I'll go to the configure options here. So we have to configure job 2 in such a way that job 2's build is done after job 1's build. So for that, we'll go to the option of build triggers. And then over here, we'll choose build after other projects are built. So once you choose this option, we want job 2's build to be done. So I'll mention job 1 here, and then I'll click on save. So you can see that this is saved. So let me go back to my Jenkins dashboard, and then let me go to this option of pipeline that we just created. So this is the view that we just created for our Jenkins pipeline. Now, if we run this pipeline, what should happen is our job 1's build should happen, and once that build is done, job 2's build should be done, right? First, job 1's build is completed, and then job 2's build is completed. So let me just run this and show you. So as you can see that job 1's build has started, and then job 1's build has been completed. After that, job 2's build has automatically started, and soon you will see that job 2's build has also been completed. And now you can see that job 2's build has also been successfully completed. So guys, that's how you build a Jenkins delivery pipeline. So that was the end of our hands-on part. So as you saw that agile practices and continuous integration go hand in hand. So you can't consider your work without continuous integration. So guys, that was continuous integration. I hope you found this video informative. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!